Hey everyone, my name is Arika. This Canadian dude named James Naismith invented basketball, and which is like the most beloved sport since forever. All Canadians are tall, I guess. You know what? I have no idea about basketball and strict sudden shots. But physics, my best friend, stand as a great tool to become better at it. In this video, we will be talking about basketball's motion projected right into the basket, which is an example of projectile motion. So the ball is projected into the air and then comes back to the surface because of the force of gravity, which makes a parabolic path or a trajectory. The ball, when thrown, some initial velocity is provided because the ball just can't teleport from your hand down to the basket. This velocity is seen in two ways: vertically, the ball reaching the maximum height, and horizontally, the ball going farther away. Here both final and initial velocities are vector quantities, which means that they both have magnitude as well as direction. Hence, we divide these two vectors into perpendicular components. Actually, this type of division of the vector into two is known as the rectangular component. And what is the value that these components have? Okay, here's a trick. These both are right angle triangles, A and B. To find base, we could use the cos function because cos is equals to base upon hypotenuse. Here, hypotenuse is the initial velocity, hence B is equals to u cos theta, and vice versa for the height using the sine function. Fun fact. By the time ball reaches its top, the ball just tends to float for a second in the air because the velocity decreases down and reaches 0 meters per second at the top. And that instant movement, it feels like floating in space. And these two motion can be represented again as mathematically. By using the second equation of motion to find horizontal motion in time t, x is equals to u cos theta times t plus half at square. Here is no acceleration horizontally, so a is equals to 0. Then x is equals to u cos theta times t, or you could just write it as t is equals to x upon u cos theta. And now for vertical motion, again by second equation, y is equals to u sine theta times t minus half gt square. Here the coefficient a is equals to minus g because the vertical direction is against the force of gravity. Now placing the value of t from horizontal motion, y is equals to u sine theta times x upon u cos theta minus half into x square upon u square cos square theta. You just like square the whole bracket. Now if we are talking about vertical motion, let's find the time for maximum height achieved. Please keep in mind that the time for the same height in straight line is different from the curved path of the projectile motion. By using first equation of motion, v is equals to u plus at, 0 is equals to u sine theta minus gt. Here v is equals to 0 because the velocity at the top is always 0. U is equals to u sine theta and a is equals to minus g. So t is equals to u sine theta divided by g. Okay, POV. A player is standing in front of you a lot far away from the basket and you gotta get that point to win the game. That simply means you need to give more distance to travel parabolically. Graphically, the best bet is 45 degrees. It is the only angle which provides the best range horizontally. Whoa, I forgot the math, sorry. For height, we use the third equation of motion. V square is equals to u square plus 2as. Placing the values, v equals 0, u sine theta, and minus 2gh. Well, because the motion is against gravity, so negative sign is used. Eventually moving some values, the final equation is h is equals to u square u square sine square theta divided by 2g. This was to find the maximum height. For range, aka the maximum distance traveled on x-axis, the second equation of motion is used, where a is equals to 0, there is no acceleration in x-axis. Hence, r is equals to utf, where tf is the time taken by the object to travel the entire parabolic trajectory. And there we go. Woof, too much math, huh? Well, you got every tool you need. Now please help me out. This question conceptualizes everything taught in this video, and please make sure to comment the answer below. And I have also linked my socials in the description where I post non-scientific stuff. Do I? I don't know. And I'll see you next time.